Hey everyone, have you ever seen a drone fly in the sky and wonder what it's for? Today, let's take a few minutes to talk about how drones are changing our world and why you should care. Drones aren't just for fun, they're used for the farming, delivery, photography, even saving lives in search and secure missions. But do most people really know that? Let's find out. Liu Shenyu, do you think drones are only used by the military? Liu Shenyu, do you think drones are only used by the military? Yes. Good. That's a common math. And what about Li Zhuoyi? Would you trust a drone to deliver your coffee?
Yes.
Me too, and it's already happening in some cities. And what is about Gu Weiheng? Do you think learning to fly a drone is difficult?
No.
Exactly. With practice, anyone can do it, even you watching this. We believe drones should empower communities. That's why we are sharing knowledge, sparkling curiosity, and enjoying you to get involved. Want to join us? Say yes in comments and we can fly into the future together.
In the next period of time, our group will conduct a research summary on drones. Let's take a look at the amazing structure of drones.
Process of designing a control system that will get a drone to hover at a fixed altitude. Now, even if you don't plan on writing your own drone controller, it's worth understanding the process because the workflow that we're going to follow is similar to the workflow you'll need for almost any control project, like drones. Also, they're just really fun to fly. To set up our control problem, we need to spend a little time understanding our hardware. In this case, the hardware already exists, so I don't have the ability to easily change the sensors or actuators in any meaningful way. Now, if you're the control engineer for a quadcopter development program, that wouldn't be the case. You would probably be expected to guide and influence the design process so that the hardware is appropriately designed to meet your control requirements. But since our hardware is already built, we have to deal with what's given to us. So let's take a look at the mini drone and see what we have to work with. We'll start with the sensors. If we flip it over and look at the bottom, there are two sensors that you can see. The one with the grid is an ultrasound sensor that's used to measure vertical distances. It sends out a high-frequency sound pulse and measures how long it takes that pulse to bounce off the floor and return back to the sensor. From the measured time, distance between the floor and the drone can be calculated, at least up to about 13 feet in altitude. After that, the reflected sound is too soft for the sensor to pick up. The other sensor is a camera. It's taking images at 60 frames per second and using an image processing technique called optical flow to determine how objects are moving between one frame and the next. From this apparent motion, the mini drone can estimate horizontal motion and speed. Now, inside the mini drone, there is a pressure sensor, which is indirectly measuring altitude. As the drone climbs in altitude, the air pressure drops slightly, and we can use this slight change in pressure to estimate how the altitude of the mini drone is changing. Is it going up or down? The last sensor is an inertial measurement unit, or IMU for short. This is made up of a 3-axis accelerometer, which measures linear acceleration, and a 3-axis gyroscope that measures angular rate. From the IMU and our knowledge of acceleration due to gravity, we can estimate the mini drone's attitude relative to gravity and how fast it's rotating. Alright, so we know that manipulating the four motors in specific ways will allow us to control the drone in 3D space. And we have a set of sensors that we can use to estimate the state of the system. And we have an onboard processor that can run our control logic. The control system development will ultimately be done in Simulink, where we're going to build and simulate the quadcopter model, tune the controller, test it in a closed-loop simulation, and then finally automatically generate flight code that we're going to load into the onboard microcontroller on the Parrot.